welcome to the channel. My name is Dr. Guru. I'm a software engineer. So in this particular video, I will be teaching you how to implement linear and binary search algorithms. But before we start writing code, okay, I want you to understand or have at least little understanding of linear and binary search. Okay, so let's dive into it. So let's look at the first one, which is binary search. Okay, sorry, I said binary search, linear search. Sorry. So binary search basically is a kind of search algorithm that works sequentially. Let's say, for example, you have this set of data, right? You are asked to find a particular datum among this data. Let's say you are asked to find this value 10 here. What linear search will do is that we start looking through all this value to get the target value, which is 10. So we start from 1, 2, 3 like that and go until you get 10. Okay, so what happened is that there is actually best case scenario when it comes to linear search, and there is actually what we refer to as worst case scenario as well. The best case scenario when you are using linear search is if the data you are looking for or the value you are looking for is either 1, 2 or 3 or so, that is let's say the value is close to the beginning, then you can easily get that value. But imagine if you are looking for a value that is at the end of your data set, then definitely you are going to take your algorithm is going to take a longer time to get to that part, which is one of the reasons why linear search algorithm is actually not the best when it comes to search algorithm, because as soon as your data increases, as your input value increases, the time it takes linear search to look for any data is going to increase as well. So, and the time complexity, which is runtime of such algorithm, is referred to as big O of n. All right, so that is the meaning of what you are seeing here. Time complexity is big O of n. That is, it takes a linear runtime. Okay, it takes a linear runtime for this search algorithm in this linear search algorithm. All right, so now the thing is, we have to check the other search algorithm, which is basically binary search algorithm. Now the idea here is actually very simple and very straightforward. Binary search algorithm is actually very efficient compared to linear search algorithm. All right, so if the way a binary search algorithm is being implemented is that it looks through the data and then determine the center value. Now it's going to compare the center value, the mid value, to the target value that you are looking for. Let's assume the target value you are looking for is 2. So it's going to compare the middle value and check if it is equal to the target value. If the target value is less than the middle value, which is 5 in this case, then it's going to eliminate from that 5 down to this end to 10, and then consider the algorithm will start considering from 4 to 1. So but what will happen again is that it's going to find the middle term between 1 and 4, and then this can actually be 2 approximately. So you now compare again. The middle term in this case, is it equal to the middle term? If it is equal to the middle term, then it will print out the value, which is actually 2. But if it is not, it's still going to compare again and ask, is the value less than or greater than 2? If it is less than 2, then it's going to cut this 2 from 2 to 4 out and then consider the numbers that are here. But if it is greater than 2, then it's going to cut from here, from 2 down to 1, and then consider the numbers, which is 3 and 4. The same thing applicable when the middle value was 5. If the target value, the value you are looking for right now, is greater than the middle value, the midpoint, then it's going to eliminate from here to this side, from 1 to 5. It's going to get it eliminated and then considering searching through the values that are at the other side. So that is how binary search algorithm works, and it is very efficient because the runtime is very fast, and when there is more input, when there is more value, the runtime only reduce in a very insignificant way, so which makes the binary search a very good algorithm. And the time complexity, which is the runtime in algorithm, we refer to it as big O of log n. That is what we call such algorithm, right? You can study more about binary and linear search to understand the mathematical concept behind them. All right, this is not the focus of this video, but how this binary and linear search can actually be implemented with using any programming language. So now let's dive into how to code binary search, and at the same time I'm going to show you how to code linear search. Meanwhile, we are going to start with linear search before we continue with binary search. So let me open my PyCharm. Okay, so I'm going to basically create a new file here. My IDE is PyCharm, so in case you wonder the type of IDE that I'm using, so Python file, I will name this linear underscore search. Okay, enter. Okay, so the first thing is I'm going to create, for you to implement linear search, first start by creating a function, and you know Python function starts with def, so I will name this linear underscore search, and we take two parameters. It's going to take list and it's going to take target. Okay, so the next thing is you are going to create a for loop to actually go through the datum in the data, all the values in the data set that is given to you. So you create a for loop. You say for I in range 0, then get the length of the list from 0. Okay, sorry for that. All right, sorry, I make a mistake here. I need to remove the length. Okay, so it's going to be length. I think this my cursor headline is too big. Okay, so now said, okay, if list, write this, target. So the next thing is I will return I. Okay, I will return I. So, but in a situation whereby there is the value, the target value is not in the data set, what will happen? In that case, you have to return, find a way to return error, or or probably don't return anything. So for me, I will say return none. Okay, and then that's it. So this is actually a function to loop through the data set and get the value that you are looking for. This is basically a linear search. Some of you might have actually been doing this, but this is basically linear search algorithm. But what we are going to do now is that I'm going to actually create another function to verify my input. So I will say def verify, which is going to take index. It's going to take a parameter. I will call it index. Okay, and I will say if index is not none. Okay, print I will say print target found. target found at let me put colon space, then I'll put my index here. Okay, else, let me take this back a little. Else I will say print target not found. Okay, let me say target not found in the list. Okay, I would like to change this one to capital letter. Sorry. Okay, here we go. So at this point I would like to create my data now. So my data sorry for that. My data, let me just put 1 and then 10. So let me see, this is my data. Okay, and then I will call my function and I will assign it to this variable called results, linear search basically. So don't forget that this function can take list. In this case our list is what? Our data. So you put your data and our target. So let's assume we are looking for 5. No, let me just say 3. That's our target. Okay, I will now say verify my results. Say verify, sorry, verify. So don't forget my verify will take as a parameter, so I will put it results. It's going to take results. Alright, so I want to copy from here. I want to copy this second line, these two last line, so that I can also verify for data that is not value that is not present in the data set. So I'm going to copy this, Ctrl C, and then come down and paste it. So this second target I will change it to maybe 20. Okay, like this. So this is basically our linear function. Okay, this is me trying to look through a data set and the data is this. Okay, then I'm checking if the index point is equals to my target and then returning my I if it is equal. If it is not equal, then I return null if it is not there. But this function basically is just to confirm or to to probably show me what is actually going on. I'm just using this form this to confirm if the value is there or not. So let's run this. Okay, so what we can get is target found at 2. So for this first one, for number 3, we have targets found at 3. That is, the index point of 3 is 2. Okay, because every array, I don't know if you are not familiar with array, I will advise you to go and read about array. Each of these data start from 0. 1 is 0. The index point of 1 is 0. That of 2 is 1. That of 3 is 2. So this is why I say target found at index point 0. Okay, so which means that our linear search actually work fine. Okay, then for the second one, the said result, I put a target value of 20 and there is no value that is 20. That is why I say target not found in the list. So that confirms a linear search. This is basically how to implement linear search. So what we are going to do right now is I'm going to show you how to implement binary search as well. So let's dive into it. So I'm going to create another file and I will name it binary search. Okay, that is binary search. All right, so don't forget what I said about how binary search works earlier. So it breaks the data set into two and then compare the middle value with the target value. So you are going to see that now in a moment, how I'm going to implement it. And I'm going to give you two ways in which you can actually, I'm going to show you two ways in which binary search can be implemented. So the first one is iterative method, while the second one is recursive method. So where the function calls itself. So let's start with the iterative method. So we have def, I will say binary search. Let me write my binary very well. Binary search, okay. Binary search. So it's going to take two values, two list and target. Okay. And target. So I'm going to create two variables. The first one is going to be the first value. The first value, which is 0, which is the first index value. So the second one is going to be last, which is going to be I will call it, it's going to be the length, the last value. I will say length, which is going to take list, and then I'm going to subtract one from it. Okay, so let me in case you don't understand what this means, if you call length, okay, of a data set, it's going to give you the actual length of the array. Let's say you have 10 values in an array, it's going to give you 10 values. But don't forget that what all these binary binary search does is that it's going to check, it's going to calculate the index point, not the value itself. So the first value is going to be 0 and the second one is going to be 1. So and if you follow it like that, an array that has 10 values, the last value is going to be 9. So we need to subtract 1 from the length of the list, so that instead of us getting that total value of the length, which is 10, we are going to get 9. All right, so that is what this is actually doing in that case. So when you are done with that, we basically create a while function. So why this function, why our condition is true, certain activity will continue to take place. So we are going to, this is what I'm going to do. You are going to say y first is less than or equals to last. Okay, equals to last. We are going to do mid point is going to be equals to first plus, let me think, I'm first, I don't know, I need to come down a bit, first plus last. All right, and I'm going to divide that by 2 to get the midpoint. So I will use a floor division. It's going to round down the value 2. And don't forget this bracket space, these two brackets, you need to put it because of operator precedence. If you don't know what that means, you need to go and read Python operator precedence. Like in Nigeria here, where I am actually making this video, there's something we refer to as board mass. So what's happened is that board mass division comes before multiplication, addition, and subtraction. Division comes. So what will happen is that if you decide not to put this first value and last value into bracket, division is going to take place before addition, and that is going to give you a wrong value. So what you want, first and last value to be calculated first before it is divided, and for you to do that, bracket need to be there, because bracket comes before division in BODMAS. That is why we have BODMAS. B for bracket, O for off, which is multiplication, D for division, M for multiplication, A for addition, S for subtraction. So bracket comes before division. So what is inside the bracket will be executed first before the division value. So you have to put this into bracket so that division will not take place before that. So when you are done getting the midpoint, then you can now say, okay, if the list, the index point, in this case, which is your midpoint, is equals to the target, is equal to the target, return midpoint. Okay, else if the midpoint, sorry, I need to put space in between this. Okay, midpoint, else if midpoint is else if the midpoint is less than the target, now it's less than the target, what will happen? If it is less than the target, we are going to add 1 to the target, and then it's going to start as the first. It's going to start at the first target. It's going to start as the first index now. So you say first equals to midpoint plus 1. Okay, so else what will happen is, okay, else last will be equals to, okay, last, then definitely if it is, what's going on, if the midpoint is less than target, then we are going to add 1 to the midpoint, and that is going to be our new first index now. Else if the midpoint is greater, what will happen is we are going to subtract 1 from the midpoint, minus 1. I would like to put space in between this and this. Same thing applicable to this. I would like to put space. Okay, all right, so that's good. So when you are done with that, if the value is not there at all, it's not in the data set, we are going to return none. Okay, so let me run you through this whole thing before we start creating we run this or test this out. Now, binary search, what is going on here is that we first set the first index and we set the last index, and then we compute, we create a condition, then we compute the middle point by adding the first index and the last index divided by 2 to get the midpoint. So if this midpoint that we get is equal to the target, we want to return the midpoint. That is the best case scenario. Okay, that is the best case scenario. If the midpoint immediately after being gotten from this line, okay, if the midpoint is equal to the target, then we want to return the midpoint. All right, but if the midpoint is less than the target, now we are going to eradicate part of the data set and start from, since it's less than, so we are going to eliminate from the upper part, and then by doing this we create a new variable and then we add 1 to the midpoint. So if the midpoint is greater than the target, then we are going to create last and then put midpoint as -1. So basically that is what's going on. You can go through the code, try it yourself and see what's going on. So what I will do is that to verify this, I'm going to go back to the linear search and copy the verify function. In fact, I will copy everything and then copy everything here because I will need it. So let me create a space here. I think this is too much. Alright, so this is my verify function. So what I will do is you just have to change this part to binary function. Change this to binary function. Do the same thing here. Binary search. Okay, so I think we are good to go. So now this is our data set. The first one we are trying out is we've put our target, and then this is going to be 3. So let's run this and see what's going on. See, we still get the same thing like before. All right, so let me change this data to 100, and let me change this one to 7. Okay, this is not contained in our data set, so definitely we are going to get target not found in the list. But here we are definitely going to get our target is found at index 0, even though index is not written, but at 0 and at 6 rather. So that's what we're going to do. Let's run this and see what's going to happen. As you can see, target not found in the first one, and then the second one, target found at 6. Binary search is always better than linear search, in the sense that binary search works faster. The run time is very fast compared to linear search. But that is not to say that linear search is not useful. There are cases or situations where linear search is used. So binary search is a very good search algorithm because of the runtime. So I will love to also show you another way in which binary search can be created. So let's come here and create another file. I will call this one recursive binary. Recursive binary. All right. Okay, so now, but before we dive into this, I want to explain basically what recursive actually means. Now, recursive is a function that call itself. Is a complicated topic actually, which I cannot even cover here, and is a little bit technical, but there is nothing impossible. You can look it up, and I bet you will understand. There are so many professionals that still find this difficult. Even me, I still find it difficult. But if you look it up, you will surely understand what recursive binary is. And in this code, I will try as much as possible to make it easy for you to understand. The function is just a function that calls itself over and over until the condition is not met again. So let's start. You first start by creating a function. I will call it recursive binary search. Recursive binary search. A function, and it's going to take list, and then it's going to take two target basically. So the second one, two parameters, sorry, a list and a target. So you create your target, the second one, target. Those are the two parameters that it will take. All right. So, well, the next thing is we are going to first check. And another thing I would like to say about recursive binary search is that it's going to actually give you true or false. If the value is there, true. If it is not there, false. But the first thing is we are going to check if the list is empty. If the list is empty, we return false. Else, we carry out another another condition. So I will say if length of list, okay, equals 0. Okay, what I will do is, sorry, this should be 2. So then I'm going to return false if it is. That's the first thing, return false. Okay, I think I make an error. I have a mistake there. return false. So the next thing is else. Else I think I have an error here. The indentation, I need to move this a little bit forward. The indentation is wrong. So in the other part, okay, now if the length is equals to 0, return false. Else what I will do is I will calculate my midpoint. Let me remove that, which is going to be equals to the length of the list, okay, divided by 2. So I will divide the length by 2. Okay, so basically what I'm doing here is calculating the midpoint. All right, so when you are done, you can then start comparing the midpoint with your target. So the first comparison that I'm going to do is I'll say if the midpoint if the midpoint is equal to the target, if the midpoint is equal to the target, if the midpoint is equal to the target, return true. Basically, return true. All right. Else if the midpoint is less than the target, if midpoint is less than the target, return return. Now we are going to return if what I want to explain here is that when you get to this part where you are comparing the midpoint with the target, if the midpoint is less than the target, you are going to call this recursive binary search. You are going to call this function again and then give the function new set of data to work with. It's going to eliminate part of the data set and then the part of this data set that is not useful anymore, and then start working with the new set. So basically what you are going to do is you are going to call this function again. So you just say return recursive, and then you give it a new list to work with. So you say list, okay, new list. So the list is going to be the midpoint now plus 1. It moves to the next midpoint, then colon. This is this function, this little column here is used in slicing array. It means that start from here to the final data set. Okay, so that is the function. You can learn how to slice data in array. All right, so when you do that, you are going to also put the second parameter, which is your target, because the recursive function need to start and then look for the need to start from the midpoint now, the next value of the midpoint, and then look for the last by looking for the target. I look for the target, so I'll put target here. All right, so now put another condition and say else return, that is if the condition if the midpoint is not less than, do this. Give take our new data set and then work with it and look for the target. But if it is less than, remove part of it and at the same time move to the other end and look for our target. So we are going to actually look for, call the recursive again in this part function. We are going to call the function again and then say list. It's going to start from the beginning, and take the midpoint. Okay, and then minus here we are going to put our target. So you put your target. So basically that's it. So next thing is to calculate. Let's create our function, verify function, to actually check for our value. So we say def verify is going to take results parameter, call it results. Okay, then I will print target found. So let me just say target found. Okay, target found. I will put my comma here, results. Okay, then the next part is now giving our program data to work with. So let me give this. I love starting my sentence with a capital letter, so let me change this to capital letter. Thank you. So the data now is going to be equals to let me quickly create 1 2. Let me just stop there. Let me add 1. Okay, so after this, the next thing is say our result therefore, call the recursive function and then give it the data and the target. So let me use 2. Okay, so I will also call the verify function now to verify that for me, and I will say results. Alright, so this is recursive function. Alright, and this is another way in which a binary search can be implemented. So basically what is here is very similar to the binary search. Okay, the only thing that is different there is this side of the function, where the side of the code, the side of the algorithm, where the function is calling itself and then working with new data sets after dividing the middle point and compare or confirm if the target is less than the middle point, or if the middle point is less than the target. So if the middle point is less than the target, definitely you will have to move higher to the next value, and then from there try to deal with those data sets, and then the other side of the values or the data are eliminated. So if the middle point is greater than the target, then it's going to start from the beginning to the end. So that is basically what this function is doing, and it's calling itself. This is why it is different from binary search. Okay, so let's run it and see what will happen. Okay, I think there is an error somewhere, so let me check that. Look for it. Line 7. Let me check line 7. Oh, sorry, this parenthesis, this is not what I'm supposed to use. I'm not supposed to use curly braces. I'm supposed to use this is what I'm supposed to use here. Okay, so let me check now. Okay, so it works now. So our target is in the data set, which is 2, and is here, so we have true. But let's change it to another data set that is not there. Let me say 70, as you can see here, and let's run it, and then you get false. So that is basically how binary search works. So what I just want to say between binary and the first implementation is called iterative binary search, and the second one is called recursive. The difference is that if you are using Python to implement binary search, I will advise you go for iterative binary search, which is the first one. This second one tends to work better with other programming language, maybe Java, Swift, and all that. But Python doesn't really work well with recursive binary search or recursive binary search. So it is better to work with iterative binary search, and the reason is based on the time complexity and space complexity of these two algorithms. This algorithm based on these two implementations. So I want you to pick binary search if you are using Python, recursive if you are using other programming language. So this is how you create linear and binary search. If you like this video and you want to see more of this and you want to learn more, I would like you to subscribe to the channel, because I have a lot of valuable information like this for you to enhance your programming skill or become a professional programmer.